I'm going to start section 2.4 on biconditional statements. Let me just give you a quick recap of 2.3. We looked at statements of this form, which is read P implies Q, or if P then Q. Okay, those are the two common phrases. I did want to remind you of, we talked about truth tables. We looked at the truth table for this statement. So, that's right up here. So P and Q. Remember, truth table keeps track of all the different possible truth values for a statement involving more than one statement. So P implies Q. We saw that there was only one case when P implies Q had a false, F for false. And that was when P is true, but Q is false. Okay? So it's true, false, true, true. So true, false, true, true. That's the truth table for P implies Q. Okay? So 2.4 is related to this. 2.3 is P implies Q. We're now going to talk about, well, what if it's true that Q also implies P? And then we'll have if and only if statements, or what we call biconditional statements. So that's section 2.4, biconditional statements. So consider this conditional statement. If n is prime, then n is odd, or n equals 2. Okay, so this is a statement. Is this statement true or false? True. It's true. Every prime number is either odd or equals 2. 2 is the only prime number that's not odd. Okay? So this is a true statement. So this is a conditional statement. If P, then Q. Right? So if P, then Q. Okay? Where P is the statement n is prime, Q is the statement n is odd or n equals 2. So now, what if I switch excuse me, the order here, and I say, look at this statement. If n is odd, or n is 2, then n is prime. Okay, another statement. True or false? It's false. So this would be if Q, then P. Okay. So we have P implies Q here. We had Q implies P here. One's true and one's false. So clearly they can't mean the same thing. They don't mean the same thing. It's not saying P implies Q is not saying the same thing as saying Q implies P. These statements mean totally different things. Okay. So it's very important that you get your implications in the right direction. P implies Q is not the same as Q implies P. But there are some statements for which P implies Q and Q implies P are both true statements. Okay?
That one if it's equal to plus or minus 2.
Sorry?
If n was equal to plus or minus 2, would it be true in both cases?
N equals plus or minus 2? Well, not every odd number is prime. So I can find an odd number that's not prime. So like 9. 9 is odd. So if n is 9, then n is odd or n is equal to 2. That's a true statement. But n is not prime. 9 is not prime. Okay, so it can happen though that P implies Q and Q implies P are both true statements. In that case, we have a new symbol for it's called if and only a statement or biconditional statement, and it's a double-sided arrow. Okay. So let me give you an example. Suppose okay, so we're talking about real numbers, a real number x. Okay, so I mean I probably should have started off with saying that n is an integer in the first, so we're not what our universal set is here. Here I'm just talking about integers. Here I'm talking now I'm supposed to talk about just real numbers. Okay, so suppose x is a real number. Let's look at this statement. So here's my P implies Q statement. If x equals 1 or x equals -1, then the absolute value of x equals 1. If x equals 1 or x equals -1, then the absolute value of x equals 1. Is this true or false? True. True. Let's look at the statement Q implies P. So how would you say Q implies P?
If the absolute value of x equals 1, then x is equal to 1 or x is equal to -1.
Yeah, you just have to change the word then to if and switch over. So if the absolute value of x equals 1, then x equals 1 or x equals -1. So remember, I specified x is a real number. Do you agree this is true? Ever believe that? And if I tell you that a real number's absolute value is 1, I must be only talking about one or two of two numbers, 1 or -1. Okay? So look at this. P implies Q, but Q also implies P. So both those statements are true. So the symbol, we could actually kind of wrap this up. Instead of saying P implies Q and Q implies P, which is kind of cumbersome, we write this symbol, P, not equivalent to, P if and only if Q. That's one way of saying it. So this symbol right here stands for, you can read this P if and only if Q. So one way of saying, so you could read the sentence, x equals 1 or x equals -1 if and only if the absolute value of x is 1. Okay? So this statement right here means the same thing as saying P implies Q and Q implies P. So, this is kind of cumbersome to write. And it's kind of, it's like a double-sided arrow, right? That P is pointing to the Q, but Q is also pointing back to the P. So it's kind of a really nice shorthand for this combination, P implies Q and Q implies P. All right. Over here.